Definition: 4D printing. 4D printing is the process through which a 3D printed object transforms itself into another structure over the influence of external energy input as temperature, light or other environmental stimuli. 4D printing is referred to as 3D printing transforming over time. 3D printing is about repeating a 2D structure, layer by layer in a print path, from the bottom to the top, layer by layer until a 3D volume is created. Overview. How does 4D printing work? Imagine having a box that was printed with a 3D printer. That alone in itself is cool, but imagine if that box could automatically flatten itself for packing once it was impacted by some stimuli. It almost sounds silly when we just consider the impact of a box going from 3D to 2D, but the impact that simple things like these can have in the business world is massive. For example, let us assume that a trucking company has a warehouse where they store all their shipping boxes. Whenever this trucking company receives a shipment of goods, they remove the goods from the boxes for delivery to their sites, and then they flatten the boxes to ship them back out to their departure points so that they can be reused for other shipments. Industry use cases of 4D printing. Healthcare. 4D printing in extreme conditions. Self-repair piping system. Aviation. Bioprinting. 4D printed clothes. Healthcare. 4D printing is to provide benefits to medical practitioners, especially in the areas not covered by 3D printing technologies. 4D printing helps to create a 3D physical object by adding smart material layer by layer through computer-operated computer-aided design data. It adds a dimension of transformation over time where printed products are sensitive to parameters like temperature, humidity, time, etc. This technology can provide extensive support in the medical field, especially with better and smart medical implants, tools and devices. Now doctors and researchers can explore with 4D printing technology to provide better service to the patient. Example. Until now, multilateral shape memory polymers. Remember their shape, actively transforming configurations over time in response to environmental stimuli. This shape memory polymer will resemble tailor-able shapes is very important for the health industry. For instance, we could make devices that will change shape or release medicine when the patient gets fewer. 4D printing in extreme conditions. 4D printing would be even more useful in big-scale projects. For example, in extreme environments, such as space, it can have very promising applications. In space, currently, the 3D printing process of the building causes some issues related to cost, efficiency, and energy consumption. So, instead of using 3D printed materials, 4D printed materials could be used to take advantage of their transformable shape. They could provide the solution to build bridges, shelters or any kind of installations, as they would build up themselves or repair themselves in case of weather damage. Example. Big antennas and other deployable devices. Protecting spacecraft from meteorites. Improving astronauts' spacesuits. Getting objects on the surface of another planet. Self-repair piping system. The platelets, small pieces of polymeric or elastomeric material, are introduced into the pipeline upstream and use the flow of the fluid to carry them down the pipe toward the leak. There the pressure forcing the fluid out of the leak causes the platelets to amass at the point of rupture, clogging up the escaping fluid in the process. Pipes that could heal themselves automatically if they crack or break, due to their ability to change in response to the environment's change. Example. One potential application of 4D printing in the real world would be pipes of a plumbing system that dynamically change their diameter in response to the flow rate and water demand. Aviation. In the aviation field, Airbus is developing programmable carbon fiber into a fuel-saving air inlet component that will cool the engine by adjusting automatically to control airflow. This ability to control airflow also has the potential to transform the cabin experience by mediating pressure and making the space more breathable for passengers. These self-reacting mechanisms will eliminate the need for less reliable, heavy mechanical control systems, further reducing fuel consumption. Bioprinting. Perhaps the most advanced version of 4D printing is bioprinting in that, once stem cells are printed, they are cultured to maturation, that is, transformed over time. Given the fact that there are now numerous bioprinting companies, it could be argued that this is where 4D printing is having the biggest impact. Example. The ability to control the maturation process is achieved in part using a custom-built CAD tool. The tool allows for the precise placement of each microdroplet of organic matter so that it can grow in a manner that is predictable based on the dynamics of cell growth. On the hardware side, the bioprinter uses a laser to eject BioLink into the proper position, as designed in the CAD tool. This is unlike any other bioprinter currently available on the market. 4D printed clothes. While most 4D printing is happening in the lab, the design studio nervous system has become famous for producing several 4D printed dresses, one of which was acquired by the Museum of Modern Art. What makes these dresses fit the definition of 4D printed objects is that they were printed as a jumble of connected tiles that, when pulled out of the printer, unfold into fully wearable garments. This makes it possible to create objects that become bigger than the printer-built platform that produced them when they are removed. Example. Created jewelry and garments with articulated joints. This allows pieces to automatically change shape once removed from the printer and placed on the model, resulting in pieces that better fit the form of any body shape. Advantages of 4D printing. Size changing. New materials or new properties. Size changing. The most obvious advantage of 4D printing is that through computational folding, objects larger than printers can be printed as only one part. Since the 4D printed objects can change shape, can shrink and unfold, objects that are too large to fit a printer can be compressed for 3D printing into their secondary form. The classic image of 4D printed objects is associated with metamaterials, that is, materials that change their shape or other physical properties depending on the environment or application. New materials or new properties. Another advantage of 4D printing technology is the usage of possible applied materials. 4D printing has a vast potential to revolutionize the world of materials as we know it today. Imagine 4D printing being applied to a variety of smart materials that today we cannot even imagine. Illustrative Example. These are some of the companies offering solutions and offerings for 4D printing. 3D Systems Corporation, Autodesk Incorporated, X1 Company, Hewlett-Packard Enterprise Company, Stratasys Limited.